All right, hello everyone, this is Mr. Crozier. I'm going to help you with our worksheet, worksheet 2.5, zeros of polynomials, worksheet number 1. We're going to do problems 3 and 4. If you didn't hear in class, this was a mistake on number 3. Instead of f of 1, this was supposed to be f of 2. So the point here is 2, 5. All right, with that mistake corrected, here we go. So our job, if you read the directions, is to use the given zeros and the solution point to write a polynomial function with the lowest degree possible. All right, so if I have these 3 zeros, 1, 2, 3, I can go ahead and write a polynomial by using the linear factorization theorem that says my formula is x minus 1, x minus a half. Now notice what I've done over here. If the 0 is x minus a half, if I take everything and times it by 2, I could convert it into 2x minus 1 as a 0. So I went ahead and did that so I don't have to work with the fractions. And then I have x plus 1, and don't forget, whenever you have a complex 0, you always have its matching conjugate here. So this is positive I, negative I, so there's my 2 roots. All right, now it's just a matter of a bunch of foiling. So I went ahead and multiplied these together first. And notice this is a plus b, a minus b. The middle terms drop out. And I have x squared minus I squared. Well, I squared we know is positive 1. Remember, you have to always remember that I is the square root of negative 1. And if you square it, you're at a negative 1. So this is a negative, which turns it into a minus a negative, which turns it positive right here. And then I'm going to FOIL, and you want to be able to do this in your head to go to here. Then we're going to FOIL all 3 of these times all 3 of the, or both of those. So it's this times this, here, 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 all the way down till you have these 6 terms. Combine the like terms, and now I have this line right here. And all that's missing in here is I don't know the a value. So I'm going to plug in from the top my x and my y, the y there, and then I went ahead and plugged everything in here. And you can use a calculator for this because it's a lot of computation. I'm going to type in 2 times 2 to the 4th power minus 3 times 2 to the 3rd power plus 3 times 2 squared. Whoops. I think I did that wrong. 2 times 2 to the 4th power minus 3 times 2 to the 2nd power plus 3 times 2 to the 2nd power. This is a 3rd power. Sorry about that. And then minus 3 times 2 plus 1. And there's my answer, 15. So all of this expression comes out to 15. If I divide that over, a is equal to 1/3. Now I can take that a, put it right back in there, and do my computation. This is 1/3 times 2 is 2/3. 1/3 times 3 is just 1. 1/3 times 3 is another 1. 1/3 times another 3 is another 1. 1/3 times 1 is 1/3. There's my polynomial. This polynomial has these zeros, and it goes through that point. All right, on the next one, number 4, same type of problem here, same logic. Here's my zeros, 4, x minus 4. Root 3i is minus root 3i. But again, complex roots come in pairs. Minus root 3i plus root 3i. I FOIL these. The only thing here is that when you have the square root of 3 squared, that's just 3. It's not a 9 there. And I squared is a negative 1, which makes this positive. And FOIL these 2 together, and I have this. Again, I'm going to plug in x for 3. If you put a 3 there, there, you get negative 12. If you put a negative 2 there, divided over a is 1/6. So I have 1/6 of this. 1/6 times this one makes it 2/3. 1/6 times this one makes it 1/2, and 1/6 times 12 makes it negative 2. And again, always put your polynomials back in order. 3, 2, 1, nothing. All right, hope this helps with your homework.